Question 1. The diagram represents a conical retaining stud, seen here. Calculate the volume of the retaining stud. In order to calculate the volume, we need the perpendicular height, and this is what we've got, so we won't need to convert it. If we'd had the slope length, that would have been different. So, let's begin. The formula that we require is V equals 1/3 pi r squared h. If you write out the formula, you can avoid errors in the next step when you're substituting. The substitution is V equals 1/3 pi, r is 7, because I've got the squared there to remind me, I'll put that in, and the height is 18. Entering that in my calculator, I get 1/3 times pi times 7 squared times 18. Just double check that. And that gives me 923.62, etc. So for my final answer, the volume is 924 millimeters cubed to 3 significant figures. Question 2. The diagram represents a steel ball bearing that is coated in zinc, and the ball bearing here is shown as a sphere. Calculate the surface area of the ball bearing. The surface area, the formula for this, for a sphere, is 4 pi r squared. We've got the radius, not the diameter, so no conversions required. So we can go straight to substituting into this formula. The surface area will be equal to 4 times pi times 3 squared. Putting this into our calculator, 4 times pi times 3 squared gives us 113.09, etc. So for my final answer, the surface area is 113 millimeters, because that's the units in this question, squared because it's a surface area, and I've rounded to 3 significant figures. Question 3. The diagram represents a cylindrical barrel with base and lid attached. Calculate the total surface area of the barrel. The barrel is cylindrical, and the total surface area of a cylinder is given by the following formula that you can get from the formula booklet. Two pi rh represents the curved surface area, and the 2 pi r squareds are the 2 circular faces, because pi r squared is the area of a circle, and there are 2, one on the top and the bottom, hence 2. Substituting in the values that we've got 2 times pi times by the radius of 35, and it is the radius, not the diameter, so no conversion required, plus the perpendicular height of 90. Then we add on the 2 circles, 2 times pi times the radius of 35 squared. Next, I need to enter all of this in my calculator. I do this in one go rather than doing it bit by bit, because that avoids errors and rounding and things like that. That gives me an unrounded value of 27,488 plus some decimals, but I'm going to round it to 3 significant figures. giving me a final answer of 27,500 centimeters squared, because it's an area, and my degree of accuracy, as I said earlier, was 3 significant figures. Question 4. The diagram represents a mass-produced conical paper cup for water dispensers. Calculate the curved surface area of the cup. Now, the curved surface area of a cone is given by the formula pi RL. That's radius times the slope length. Let's check that those are what we've got. This is indeed the slope length rather than the perpendicular height, so that's useful. But this is the diameter rather than the radius. The radius is equal to the diameter divided by 2. So we can work out that the radius is 60 divided by 2, that's 30. So we can use this value in our calculations here. The curved surface area is equal to pi times 30 times the slope length L of 80. Entering this into our calculator, and we get a curved surface area of 7539.8 and so on. When rounded for our final answer, the curved surface area is 7540 millimeters squared to 3 significant figures. Question 5. The diagram represents a cylindrical oil drum. Calculate the volume of the oil drum. The volume of a cylinder is given by V equals pi R squared H, as seen in the formula sheet. We have these values. This is the radius, this is the height, so we can substitute them directly in. Entering those into our calculator, we get a value of 346360. There are some decimal points, but I'm only interested in a number of significant figures, so I'm going to round it now and get a volume of 346000 centimeters cubed to 3 significant figures. Question 6. The diagram represents a spherical vessel for storing high pressure gas. Here it is. Calculate the volume of the storage vessel. The formula for the volume of a sphere given in the formula sheet is V equals 4/3 pi R cubed. And if you write that formula out, it avoids errors when substituting in a moment. We need the radius. We have the radius, so we can proceed directly to substitution. Entering that into our calculator, and we get a value for the volume of 1.0980 and so on. Rounding for our final answer, the volume is 1.10 meters cubed to 3 significant figures. Question 7. The diagram represents an extruded plastic bar in the shape of a pentagonal prism. The area of the pentagonal face is 3.7 centimeters squared. The pentagonal face it's referring to is this front face here, or indeed it could be the back face, since in a prism all the way through the cross-sectional surface area is the same. In order to calculate the volume of this plastic bar, we need to know a formula that is not given in the formula sheet, and that is that the volume is equal to the cross-sectional area times by the perpendicular height. Now this doesn't look like a height because it's going along rather than up and down, which is what we think of as height. But if you lie down, you're still just as tall. This is the perpendicular height. It's the one that's perpendicular to the cross-sectional surface area. So our area, we were told, is 3.7. So we can substitute that in for the area. The height is 6.2. If we enter those into our calculator, we get 22.94. Rounding that, 22.9 centimeters cubed to 3 significant figures. Question 8. The diagram represents the conical nose of a rocket. Calculate the volume of the nose cone. The volume of a cone is given in the formula sheet as 1/3 pi r squared h. Let's see if we've got those variables in our diagram. The radius is shown, that's useful. The height, however, this is not the height, this is the slope length. The height would be perpendicular, straight up and down. So we need to convert this slope length into a height. There is a formula you can remember for this. It's not given in the formula book, but it's basically just Pythagoras. You might have heard a squared plus b squared equals c squared, or c squared equals a squared plus b squared. This is a rearrangement because we are trying to find one of the smaller sides and we've got the hypotenuse. If you want to remember this, or if you want to play around with some Pythagoras to make sure you're familiar with this method, that's what you need to do. So in order to find the height, we need to take the slope length of 7.4, square it, and subtract the radius of 4.2 squared, and all of that is being square rooted. In the calculator, that gives us 6.0926, but if I keep that in my calculator display, in the next stage I'll be able to use the answer button, and I won't have to worry about having rounded this or about having any error introduced that way. But I have now got a value for the height, which is what I want here, so I can continue. Entering this in my calculator, I get a value of 112.54 etc. Now I've truncated it here, but this is actually exact because I've not used a rounded value. I've used my original answer from the last time I used the calculator. Therefore, for my final answer, I can round this with confidence that I've not introduced a rounding error. I've got 113 meters cubed to 3 significant figures. Question 9. The diagram represents a stone block prepared by a mason working on the restoration of a castle. Here it is. Calculate the volume of the block. Now looking at this block, I can see that it is a triangular prism. The formula for prisms is not given in the formula book. You need to know it. The formula is the cross-sectional area times the perpendicular height. Now I mentioned before about these heights. This is a height even though it is horizontal. It's perpendicular to the cross-sectional area. That's just what we call it. So I've got the height, but I've not yet got the perpendicular area. That's a triangle, so I can find the triangle's area. It's going to be equal to half base times height. Substituting in the values that I've got, that will be a half times 43 times 28, and with my calculator I get 602. That would be centimeters squared. Since there's 4 marks for this question, we might as well make a note of that there. So we're definitely on for at least part marks. Now that I've got this, I can work out that the volume of the prism will be equal to this area times by the perpendicular height of the prism. Now, it's easy to get confused. The height of the triangle was this. That's just like a normal triangle, base times height. But the height of the prism is this one here. So don't get mixed up with those two things. They're both labelled height, which is a little bit unfortunate. And when we evaluate those with the calculator, we get 40,936. For our final answer, rounding to 40,900 and giving centimeters cubed as our units, as well as stating the degree of accuracy. Question 10. Longpack Co. Limited are manufacturing components for the board game Cones of Dunshire. The diagram represents a playing piece constructed of a solid cone of plastic, and you can see that here. Calculate the total surface area of the Cone of Dunshire, including the circular base. The circular base and the curved surface area together make up the total surface area. Now, we're not given a formula for the total surface area, but we are given a formula for the curved surface area. So let's start with that. It's pi r L. Now, r stands for the radius, and we have that. It's 16 millimeters. But L is the slope length. We don't have the slope length, we've got the perpendicular height. So we need to use that Pythagoras trick to get the slope length. The slope length is equal to the square root of the height squared plus the radius squared. Substituting in our value for the height of 63, squaring it, and adding in 16 squared. With our calculator, we get an answer of 65. We can now substitute that into the formula for the curved surface area. Remember, this is just the curved surface area. Now, I could enter that into my calculator and evaluate it, but I'm not going to. I'm going to leave that until later. What I'm now going to do is I'm going to work out what this circular base, what the area of that is. Now I know that the base is a circle, so it will have an area of pi r squared. That would be pi times 16 squared, because the radius is 16. Now that I've got the curved surface area, or an expression for it, and the base, I can get the total surface area by adding the curved surface area to the base. The curved surface area is pi times 16 times 65 plus pi times 16 squared. Now I'm going to enter this into my calculator. Pi times 16 times 65 plus pi times 16 squared. That gives me a value unrounded for the total surface area of 4071.5, etc. I'm going to round that to get a final answer of a total surface area of 4070, and it's millimeters squared, and I've done it to 3 significant figures.